So you have my graph's a function, and she thinks it looks like a parabola because it comes down and goes up, which is what a parabola looks like. So it must be a quadratic function, quadratic polynomial. You, with your team, are going to determine if she's correct. You're going to use graphing technology to check and explain how you could select a viewing window before graphing an expression like this so you could see all of the main features of the graph. Okay, so let's take a few minutes to do that on your own and we'll talk. Okay, so we've talked about it. I think we might have written it down once. So let me give you an example of a quadratic and see if you can figure out what that would be. So quadratic, here would be an example of a quadratic polynomial. 2x squared minus 7x plus 3. That would be a quadratic polynomial. So anybody think they know what a quadratic is now? So what does it have to do with? Do you think it has to do with the terms itself or something about one of the terms? Okay, which term? The first one, and what am I looking at? The squared, okay? So quadratic means second degree polynomial. So now that you know we're all on the level set page of what a quadratic is, now you should be able to answer the question, is mine correct or not? And then go from there. Okay. So how do we know it's wrong even without looking at the graph? Remember, factors. I've got one factor with an x, second factor with an x, and a third factor with an x. So if I've got three factors with an x, and I multiply x times x times x, is that going to be x squared? Nope. Okay. So it's cubed. So let's go ahead and put this into Desmos. If you want to save this stuff from today, you need to do two things. You need to make sure you're logged in. Okay. And you need to give this thing a name. So if I click here, we're in unit 2, and I'm going to call this Algebra 3 because I teach multiple algebra classes. You don't have to put the Algebra 3 in there if you don't want to. And this is lesson 7. All right, so I'm going to keep my stuff from a warm-up, but I don't want them active, so I'm going to turn them off. And then, I don't know, maybe make a folder, call it 7.2, so I know where I'm looking at stuff. Hit enter, and somebody help me out. X minus. What? X plus 1, X minus 1?
P of x equals.
Oh, x plus 1.
X plus 1.
X minus 2.
X minus 2.
X plus 15.
15?
Yeah.
All right. So, doesn't look like she's wrong, does it? Okay. What you have to notice is that 15. So if we establish the relationship between the factors and the zeros, okay, so what that really means is I've got that is one of my zeros, and that's connected to x plus 1. This is another 0, and that's connected to x minus 2. And my third 0, where would that be?
To the left.
A lot to the left. So if I know I have to go to the negative 15, I might change my window and go to negative 20. You got this. Okay? All right. So, and then if I want to see a little bit more, little pinch, pull down, pinch. I want to be able to see my relative max and min if possible. This is a very high max. It's upwards in 540. Okay. So you have to modify your window quite a bit if you wanted to see your relative max and min.
So x is negative.
All right, so let's save that. Let's come back here. So we come up here and say, all right. So is mine correct? No. Okay. So what was her mistake? Her window was too tiny. How about restricted? Okay. So, no. Okay. So how do you select a viewing window before graphing?
You have to look at the.
Look at the how do we look at the intercepts? We look at the factors, okay? So we look at the factors that determines the intercept, and that would have helped us. Might not have found, it doesn't really clearly show how to modify the y-axis, but definitely the x-axis, okay? So use the intercepts from the factors. So use the factors to determine x-intercepts first, okay? And at the very least, you could also find the y-intercept. How do you find the y-intercept? Multiply all of the numbers inside. Okay, so we're looking at 1 times -2 times positive 15. So that's negative 30. And if we look, we can double check here. It doesn't look like negative 30 because we're so zoomed out. But if you click anywhere close to the y-axis, there you go. 0, -30. Okay.
Whoa.
So every time you create a graph, Desmos will do some really nice things for you. Okay, once I click on one critical point, it tells me, hey, there's my intercepts, that's my y-intercept, that's my relative max, and then if I click just a little bit to the hair, that's my relative min. Okay. So Desmos is very kind in the information it will provide if I know how to utilize it properly. Okay. So based on that, let's just worry about, so y-intercept is, let's finish that off. Product of numbers inside. Let's rephrase this a little bit. Product of numbers. Let's say product of x-intercepts. Intercepts. And, because we didn't see it in this one, any numerical factors. So let me tell you what I mean by that. So in the previous problem, we put a 3 in front. So that was not a binomial factor, but it was a numerical factor. It was the number 3. So, and we actually figured out what it was up here. Okay. So we said 3 times -5 was -15, times 3 was -45. So don't forget about the numerical factors. That's going to determine your y-intercept. All right. So figure out what your x-intercept and just your y-intercept, and figure out at least a good window as far as x is concerned. Y on this one is cray-cray because of the 28 makes it huge. So just give me what my minimum x should be and my maximum x should be for the window. That's all. Okay. And we're going to skip the ready for more because that was completely insane. Just looking at the x-intercepts, we're going to make an equation editor, and we're going to write it this way, and then we can easily transfer it to Desmos. So what's my smallest x-intercept? Not that small. -1. Okay. So if I'm going from -1 and I want a little bit of a cushion, how about negative? That's a little extreme. 5? 10? Either one. I'll start with 5. Less than x, less than, this one's kind of big. Okay, so go to at least 30. Yep. So all of my other x-intercepts. How many intercepts will I have? I got 4 factors, and they're all different. So I should have 4 intercepts. Say this was x plus 1. Well, now that's x plus 1 twice. And now how many x-intercepts do I have? I don't have 4. I'm down to 3 because this one's going to repeat. Okay. What would be a better way to write that instead of x plus 1 times x plus 1? What's a more compact way to write it?
X plus 1 squared.
X plus 1 squared. Okay. So keep all these in mind because in the not too distant future, we're going to be talking about things called, ready? Multiplicity.
What the heck?
Multiplicity. So multiplicity here, all the multiplicities are 1. If I change this to a plus, one of my factors has a multiplicity of, is that hard? So it sounds weird, but it's not hard at all. We'll talk about that more later. All right, So we're going to skip Are You Ready for More? Come down to what's the equation. So it's kind of like Jeopardy. They're giving you the intercepts. You need to come up with a polynomial. So we're all going to start with y equals. Okay? So here's how you do this. Really simple. The 0 tells us what we start with the equation. So I'm going to start over here. Do x minus 4 equals 0. Okay? And then we solve that. I'm sorry, x equals 4. I just gave it away. X equals 4, and we reverse solving it. So we set it equal to 0. So we subtract 4 from both sides. And we subtract 4 from both sides, we get x minus 4. And that's all. Just double check, see what it looks like. Control A, Control C. Now we're going to 7.3, so I'll make a new folder. Since I don't want this kind of big beast here, I'm going to turn it off. I really want to see all those numbers. So go home. Okay. And now let's paste it in. Okay. That doesn't look like a quadratic. What kind of function is this? It's linear because it's a line. Okay. So this is a first degree. So let's kind of put that somewhere too. So lines are first degree equations. We never really answered the thing with my. Oh, if we had 3 terms, that's not quadratic, so what would it be? We have first degree, we have quadratic, and we have cubic. So third degree equations are cubic, okay? So let's put that in there too, okay? So cubic. We've talked about all this, but I don't think we kind of put it all together. Okay. All right. So here's what I want you to do. I want you to come up with 4 more equations for the rest of these. This last one we're going to modify probably just a hair. I'll talk about why a little bit later. So does it say standard form? So what do you not have to do? So what does that mean? So far, these are all what? It's not standard form, and I have a bunch of factors that I'm multiplying together. Maybe this is factored form. So am I asking you to multiply these out? No. Because I was multiplying out, it would be standard form. Standard form, no parentheses. Standard form is like this. No parentheses, everything's multiplied out. Factored form is like these. So since I'm such a nice guy, just asking for these in factored form. Okay, so do the next 4. Shouldn't take you too long. So we've established x minus 4 when we have 4 zeros. So can we reuse that again? Sure. So, but since we have a second one, maybe we should put x minus 4 inside of some parentheses. Okay, so y equals. All right. So why is this a little bit silly? It's not silly, it's just not simplified. Because x minus 0 is just x. So we don't even need parentheses for this one. Okay? And can I move the x in the front if I wanted to?
Yeah.
And usually if we don't have something in parentheses, we're going to move it in the front. It's okay to put in the back, and it's okay if you had a parentheses with a minus 0. No. That's not simplified. Okay? Hey, look! I have the same 2 x-intercepts. Can I use this as kind of a starter equation? Yeah. Control A, Control C. The only thing different is now I've got -2 as an additional intercept. So if I have an additional intercept, I need an additional factor. Okay. What do you got, Aiden, for that one? I got -2 as an intercept. What's my factor? If -2, 0 is my intercept, what is my factor associated with that intercept? x plus 2. We need to put that variable in there too. This kind of looks like this, doesn't it? Except my intercepts are switched, so I can do a little control A, control C, control V, and just change my minus to a plus, my plus to a minus. Easy peasy. So far so good? Now the fly in the ointment. What do we think the fly in the ointment is? I know you know. I'm going to get somebody else. What's the fly in the ointment? The fraction. Okay. So still not too bad. So there are multiple ways, and I want you to look at the instructions. It says, write a, ooh, look. That means there can be more than one, right? So if I wanted to get fancy with any of these, what could I do in front of any one of these equations? Throw in a number. Any old number you want. Because what happens to the x-intercepts? They don't change. What's going to happen to my y values? They're going to go crazy if I put something that big in there. Okay, so it says possible equation because there are an actual infinite number of equations. I could even get like negative 0.09. Okay, I think I got a letter in there, and that should be a decimal point. Okay, that would still be a legitimate equation. Okay, I can have real number coefficients. It's just going to look weird. All right.
I think I have one. I don't think it's right on.
Oh, I love undo. Undo. All right. So let's come back here.
That's what I got.
So far, let's deal with the first one and the last one. So y equals, I'm out here, Layla. -5 gives me x plus 1. Okay. And Emilio, how about 3? 3. Minus 3. So that means the last one would be x minus a half. And I want you to listen very carefully to what I'm about to say. This is not wrong. However, especially on a multiple choice test like you see on your unit test, you probably will not see this. Okay? So, if you have it already, great. I know William has it. You got it too. Yep. Christian's got it. So let's go back to what we did before. Let's do x minus a half equals 0. And let's rewrite this without the fraction. Because more times than not, if you see this on a multiple choice, you're not going to see a fraction. So how do we eliminate fraction? Just one little simple thing to do. Not reciprocal by the denominator. So I'm going to put this whole thing in big old parentheses. And Cami will be so nice to do that for me. When I multiply everything through by 2, what happens? In front of the x becomes 2, and 2 times a half is 1. So this is more likely what you're going to see. Okay. And if I want to get really fancy, remember there's an infinite number of solutions here. Isn't that going to give me a half?
Really?
How about that? That can give me a half?
Did you do the same thing for the other one?
Yeah.
Like you could make it 2x and then make
Yeah, so up here, in that case, if I multiply both of them by 2, that's also going to give me the same x-intercepts. Doesn't make a difference. I can put 1 there. I can put a 3 here. Just got to remember, I have to multiply everything through by the same thing. So if that's 3, this is 6. I come over here. I can call that 9. And this is going to be 36. Just have to multiply everything through by the same thing. Okay? But let's just make it a little simpler. So let's go back to what we did. Uh-oh. Oh, okay, fine, be that way. So what was that? X minus 2x minus 1, right? All right, and this one was just x plus 2. So, in summary, we can use zeros to find the expression of what the polynomial might be. Remember, there's an infinite number of choices, but if you want to keep it simple, what should our leading coefficient be? 1. Okay, if you don't make it 1, or you're not told to make it something else, don't change it. Okay. You have many possible expressions, so you can see what they did here. They took each of these points and did what? They have a little bitty
They changed the
2. Well, it didn't just change the y-intercept. It changed every single point on the graph except for your x-intercepts, because my y values and my x-intercepts are 0. When I double 0, I still get 0. Okay? Questions? That's it. Okay? We're done. What I want you to do